Now I want to discuss the non-mechanical properties. This means the characteristics of the material that affect selection, use and performance. Like the non-mechanical properties are density and unit weight, thermal expansion and surface characteristics. So what is density? Density means density is the mass per unit volume of material. It is denoted by rho. Rho is equal to mass by volume. Then unit weight is the weight per unit volume of material. Gamma is equal to rho multiplied by g. Specific gravity. It is the ratio of the mass of a substance relative to the mass of an equal volume of water at a specified temperature. So specific gravity is equal to rho m over rho w. So here I want to explain this about thermal expansion. Thermal expansion means all materials expand when the temperature increase and contract when the temperature decrease. So we have a coefficient of thermal expansion. The amount of expansion per unit length due to 1 unit increase of temperature. The amount of expansion per unit length due to 1 unit increase of temperature. See here formula alpha L. Alpha L means linear coefficient of thermal expansion. It is given as delta L over delta T whole over L, where L is the original length of the specimen. Like coming to alpha V is equal to delta V over delta T all over V. V is the original volume of the specimen. Sometimes they may be asking like we should determine the change in length, because when the temperature increases or decreases we have to determine this change in length. Whereas linear coefficient of thermal expansion was given by this manufacturer, in examination point of view it can be given in the question. And delta T, obviously they will give this temperature increased or temperature decreased. Delta T is difference of temperatures. L is original length of the specimen. If you want to determine this change in length, you can use this formula. At any case, if you want to find out this coefficient of thermal expansion with the values, so that you can use this formula. So we have a problem here. A steel bar with a length of 3 meter diameter, a modulus of elasticity. I'll explain it on the board so that you can understand easily. Dear students, so I am going to explain another problem. So already it is in slide 20. A steel bar having a length of 3 meters and diameter of 25 mm, which is having the modulus of elasticity E as 207 GPa, and it is having this linear coefficient of thermal expansion as 0.000009. This is like the change in temperature is in meters and degree centigrade. The ambient temperature and that ambient temperature for the steel rod is 40 degrees centigrade. But here the temperature has been decreased to 15 degrees centigrade. The temperature has been decreased to 15 degrees centigrade. So the question has been asked like this: what internal stress will develop due to this temperature change? Is this stress tension or compression? Why? You have a steel rod like this. The dimensions of the steel rod is 3 meter and the dimension is 25 mm. So these are the Young's modulus is 207 GPa. This linear coefficient of thermal expansion is 0.50 after before 9. So now let me explain you this concept. If the beam, you have a material like this, if it is fixed only to one end, like if it is a fixed only to one end, if there is an increase in temperature or decrease in temperature, the material can have a freedom to extend or to elongate or to contract. So it can be happened only when this material is fixed only one end. But in some condition, like the given condition, the logic is that the bar was fixed at both the ends. It means that the bar was fixed at both the ends. So when the bar was fixed at both the ends, it cannot elongate or it cannot contract. Due to this, the bar has fixed up like this. So when the bar is fixed like this, it tries to move, but these fixed ends cannot resist, cannot allow them to move. If they want to contract, these fixed ends cannot allow them to get contracted. So here this is the problem. So at this time, there will be, this material tries to extend or elongate or contract, but these fixed supports is resisting or acting in opposite direction. The force is acting in opposite direction. So at that time, here there is a chance of a stress developed. So here some stresses will be developed. So the question has been asked that what type of stresses are developed in these areas. So we have to find out the stresses which are developed in these areas. So here you can see in the video, if the bar was fixed at one end and free at the another end, if the bar was fixed at one end and free at another end, the bar would have contracted and no stresses would have developed. In that case, the change in the length can be calculated by using this equation. So here what we are doing is, we assume that the bar was fixed at only one end. So to find out this change in length and everything, as of now we will assume this bar was fixed at only one end. So this bar have tendency to get elongate or to contract. So as the temperature is decreased, the material is going to get contract. So the length of the rod, like 3 meters, will decrease some amount. So how much decrease? We will find it out. We will find it out, the delta L. So what is delta L here? We have a formula from this previous equation. So in the previous slide you can find it. Delta L is equal to alpha L into delta T into L. So before that you find out delta T. Delta T is change in temperature. Like the change in temperature means T dash by T. It is 40 degrees centigrade minus 15 degrees centigrade. Sorry. Like T dash is 15 degrees centigrade minus 40 degrees centigrade. So the delta T is minus 25 degree centigrade. So from this we can determine this delta T as minus 25 degrees centigrade. So already you know this alpha L 0.000009 into delta T is minus 25. The length is given as 3. So you can determine this how much is delta L. So if you solve this equation, you will get answer of minus 0.000675 meter. So you want to calculate strain. So strain, we have formula delta L by L. What is delta L here? You got delta L as minus 0.000675 meter divided by what is the original length, 3 meter. So if you solve this, you will get an answer of minus 0.000225 meter. So this is like we calculated delta L, the change in length. So the steel rod affected with the decrease of the length, it can be reduced by minus, it may be reduced by minus 0.000675 meter. The strain in this rod is delta L by L. It is minus 0.000225 meter. So this is the strain developed due to this rod. Now, since the bar is fixed at both ends, now in our condition, the bar is fixed at both ends. Our bar is fixed at both ends. The length of the bar will not change, so the bar length cannot be changed. Therefore, a stress will develop here. What is this stress? This material wants to get contracted, so it wants to get contracted. But here these fixed ends are not allowing, and they are allowing to act, they are giving a force in this direction. So if the stresses are developed in this direction, which is elongating the material, that stress is tensile stress. So here you can answer that in a problem, what internal stress will develop due to this temperature change. So you can say that the tensile stress, the internal stress is developed is the tensile stress. So then how much you can, what is the stress, or you have to find out the stress, how much stress it is. Stress is the formula, already you know, stress is equal to like sigma force by area. But we don't have any force here, we don't know any force, we have you don't have area. So that you can find out this from another equation. We have equation like Young's modulus is equal to normal stress by normal strain. So previously we have calculated stress and we have calculated strain. So we have to calculate stress and we calculated strain. Already Young's modulus given 207 GPa. So sigma can be written like Young's modulus into strain. Young's modulus is 207 GPa. And the strain is, which you got in the previous one, 0.000225. Okay, so 207 GPa, you can write it as 1000 MPa. So if you multiplied it, minus 46.575 MPa. It is minus the stress developed, the tensile stress developed in this bar is minus 46.575 MPa. So finally, you can say that if this bar was not restricted to increase or decrease, so here the original length is 3 meters. So from the previous calculation, the bar can be reduced by minus 0.000675 meter. So the bar is reduced to 0.000675 meter. So that what is the present length of the bar? If it was not restricted or it was not restrained by this fixed ends, this can be 3 minus 0.000675 meter. It can be, it is like 2.999325 meter. So from this you can understand this bottom line which was given. Okay.